In the previous video we have seen that we are going to have the timing circuit or the sequence counter in order to generate the timing signals like T0, T1, T2 so that some of the instructions can be executed, some of the micro operations, not just instructions, can be executed at those particular instances of time. Irrespective of whatever the instruction it is, if you have to execute it, you have to load it into the instruction register. Therefore, you have to definitely do those two actions. One is sending the program counter into the address register, and the other one is loading the word from the memory into the instruction register. These two things have to be done whatever the instruction it is, irrespective of the instruction. That is why I was directly connecting the timing signal to those inputs, right, control inputs, so that these things will happen automatically at T0 and T1. But then there are certain kinds of operations which will be dependent on what the type of instruction it is. So we should also do some actions based on what type of operation it is. In order to find out the type of operation, you have to analyze the opcode, right? And for that reason we are going to use a decoder. So try to understand this one. We have now assume that we have now loaded the instruction on into the instruction register. Assume that this is instruction register, okay, and we know that a part of it is operand 0 to 11, which means this 12 bits is going to contain operand, and then 12, 13, 14, 15. These 4 bits are going to give us the opcode. This is the operand field and this is the opcode field. Now, in order to analyze the type of what type of operation it is, we are going to use a decoder, right? And the way we are using this instruction format is, first bit is going to say what type of addressing mode it is. So in case of our computer, we are going to use only two types of instruction modes to keep it simple. In general purpose computers of the present day, we have a lot of addressing modes, but here we shall limit ourselves to using only two types of instruction modes. One is direct instruction mode or direct addressing, and this other one is indirect addressing. Direct addressing means wherever the operand is present, that address will be given here. Indirect addressing mode means the address which is present here, you have to go to that particular address. There you will find the address of the operand, which means effective address has to be loaded from the memory in order to get the operand. Got it? So you please refer to the topic of addressing modes, which we have discussed in a different topic, then you can understand these two, direct and indirect. So I indicates that if I is 0, it indicates that direct is used. If I is 1, it indicates that indirect mode is used. And now these 3 bits, the remaining 3 bits, are going to give us what type of operation it is. For example, okay, so we shall see the types of operations later. Here let's see how to decode it. Now these 3 bits are going to form inputs to 3/8 decoder. Okay, now these 3 are going to form inputs. Let's say this is the input, okay, these 3 inputs, and then the outputs are going to be 8. 1, 2, 3, 4, 5, 6, 7, 8, right? And each output will represent certain type of operation: D1, D2, D3, D4, D5, D6, D7. Earlier I have shown you how timing signals will be useful in order to perform certain operations. Now I am showing you how the type of instruction will be useful. So let us assume that after finding it out, we have found out that, just for the sake of simplicity, I am taking a small example which is not actually real. It doesn't exist in this computer, but it is the only example I could come up with. Assume that this particular instruction D5 is increment accumulator. Okay, so which means you have this accumulator and you have this increment input to the accumulator. D5 is the instruction which is saying increment accumulator, then D5 will be connected to this. So whenever the type of instruction happens to be increment accumulator, it will automatically be triggered. But it is not that simple in the real world. Earlier we have seen what is the timing signals, and now we have seen what is the type of instruction it is. Now actually both have to be combined, which means see this, our control unit is going to have control logic gates which will actually give out the control signals, which will go into this resistors and all the ALU. Now to this control logic gates, the inputs will be, one will be this decoder, instruction decoder, and other will be the timing circuit, right? So T0 to T15 will be given, and then D0 to D7 will be given, and both of them will be seen together, and then certain control signal will go on to the certain register. For example, this increment operation might have to happen only during only after a certain phase. And how can you identify that? Depending on what type of what time it is. For example, D5, let us say this is D5, has to happen at T5 or T4. Then T4 and D5, whenever both happens to be together, which means if the time now is T4 and the instruction now happen to be D5, then only certain thing has to happen or certain gate has to be triggered. Then we combine both of them in an AND gate and we supply the signal to that particular thing. So if you look at it, everything is being done using the hardware. We are not going to use any program. That is why it is also called as hardware design. And in order to implement everything, we need these two main things. One is the timing and the other one is the decoder, right? We are going to combine these two and we are going to supply them. Now how to combine these two, that we shall see by taking example of what type of instructions there are and what is the instruction cycle. In order to execute an instruction, it is not just about the execution phase. Instruction cycle will contain various phases, and each phase will happen at certain timing, and some actions will have to be done based on what type of instruction it is. So at that point we are going to combine everything together. So don't get confused. The actual thing is simple. We have two different types of circuits or the hardware units which are giving us signals, and by taking the signals we'll again combine them using the logic gates and then give the signals to the all the units present there. So all of them will work together and perform an instruction. Okay, don't worry, we shall go slowly. I'll take everything from basics. From here on it is very important, try to understand it. If you understand whatever I am going to teach from here on, you will understand pipelining easily. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.